Hi guys, today and tomorrow's lessons are going to be on looking at tolerance in a real life context and solving problems. So we already know how to find maximum and minimum values and how to express a range of values in tolerance form. But now what we're going to look at is applying that to various real life situations. So the first one says a company that sells candles will only approve a batch if 80% or more are within 300 grams plus or minus 12 grams. So talking about the weight of the candles. The weights of a batch in grams are shown below, and we have 10 different candle weights. Will this batch be approved? And we're being asked to justify the answer. So when it says justify, you know that you're going to have to justify it involving numbers. You can't just say yes or no. So first of all, we're going to work out the maximum and minimum candle weights that will be accepted. So the maximum will be 300 plus 12, which is 312 grams. And the minimum weight accepted would be 300 and minus 12, so 288 grams. And we're going to go through each of these 10 candles that are up here, and we're going to make a decision about whether or not they would be accepted and approved for sale. So the first one is 310, which is acceptable. The second one is too big because it's bigger than 312. The next one, 298, is acceptable. The fourth one, though, is too small. It doesn't weigh enough because our lower limit is 288 grams. We can put a cross next to that one. 312 is accepted. It wouldn't be accepted if it was 312.1 or even 312.01, but the maximum acceptable answer is 312. So anything that is on your threshold, so bang on your maximum or minimum, will be accepted. So will 307, 290, 303, 299, and 308. So we still haven't answered our question, which is, will this batch of candles be approved? And remember, our criteria for approval is that 80% or more of the candles have to be within that 300 grams plus or minus 12 grams range. So we want to look at how many of the candles were accepted, and you just count up the number of ticks there. So we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 candles were accepted out of 10, and we have to, without a calculator, turn that into a percentage. So 8 over 10 is 80%. And again, we've still not answered the question because we have to say yes or no. Will this batch of candles be approved? So because it says 80% or more, we can say yes, it will be accepted. Because 80% of the candles are within our tolerance interval. And we can just write are within 300 grams plus or minus 12 grams. Don't worry if your sentence is a little bit different to mine. Okay, that's all right, that's totally fine, as long as you say yes and back it up with some numbers. Our second example is another context problem, and it says a car's speedometer is accurate plus or minus 5 miles per hour. If a car travels for 2 hours and the speedometer reads 45 miles per hour, what is the longest and shortest distance the car could have covered in that time? So this is a speed, distance, time question. We're being asked to find the distance. We know that the time is 2 hours, and we know that the speed is 45 miles per hour plus or minus 5 miles per hour. So the first step is to find the maximum and the minimum speed. We're going to be doing speed, distance, time twice here. We're going to do it once to find the maximum distance and then again to find the minimum distance. So the maximum speed will be 45 plus 5 miles per hour. which is 50 miles per hour. And the minimum speed will be 45 minus 5, which is 40 miles per hour. So we should know from speed, distance, time that if you are travelling faster for the same length of time, you'll cover a larger distance or a greater distance than you would travelling for the same length of time at a lower speed. So we're going to do distance equals speed times time. If you can't remember your little triangle, I've just drawn it at the side there. So we're going to use distance equals speed times time. So our maximum distance will be our maximum speed, which is 50 miles per hour, multiplied by the time. And over on this side, our minimum distance will be the minimum speed, which is 40 miles per hour, multiplied by the time. So the time doesn't change. The only thing that changes here is the speed, because that is what our tolerance is relating to. So the maximum distance travelled is 100 miles. And the minimum distance travelled is 80 miles. There are a few questions like this in the exercise that you're going to be working through. One thing to pay attention to in that exercise is that if the time isn't just a certain number of hours and it's hours and minutes, that you convert it into decimal hours before you put it into your formula. The third example and the last example we're going to look at is about a maximum possible length of a fence. So if a fence is to be made up of 18 panels of wood and each panel measures 135 centimetres plus or minus 0.2 metres, we're asked to find the maximum length of that fence. So what you should notice straight away here is that we have 135 centimetres but plus or minus 0.2 metres. So we have to convert both of these into the same form, otherwise we're not going to be able to find a maximum and minimum value. What I would do here is I would convert the 135 centimetres into 1.35 metres. It doesn't really matter what way you do this, to be honest. You're going to end up with the same answer at the end, regardless of whether you convert them both into meters or centimeters. I just think this way is easier because we're going to be multiplying it to make it a bigger number. So because this question is only asking us about the maximum length, we don't have to work out the maximum and minimum. So when you're reading these questions, make sure that you pay attention to whether it's asking you for just the maximum or just the minimum or both, because if it only asks for one, then you can save yourself a little bit of work by not having to work out the other one. So 1.35 plus 0.2 is 1.55. So the maximum length that each individual panel of wood can be is 1.55 metres. So the maximum possible length of the fence would occur if every single panel of wood, so every single piece of those 18 pieces of wood, is the maximum of 1.55. So if we're working on that assumption, we'll say 1.55 times 18, and you can use a calculator for this. It gives you an answer of 27.9 metres. And that's your answer. If you had worked it through in centimetres, you would get the same answer in the end, but what you would end up with is 2,790 centimetres, which you would then have to divide by 100 to convert into metres. So this video will cover today and tomorrow's lessons. So there isn't a new video for tomorrow's lesson, but feel free to re-watch this one just to refresh yourself a little bit before you tackle the questions that are in the booklet for tomorrow.